Hello, and today we're going to talk about some Bronsted acid and base problems. Alright, so we need to label out. First, the problem asks us to label the acids and the bases and the reactants. And so, just from looking at this, we can kind of already gauge, well, you know, that CH3OH looks more like an acid than the NH2. Now, that is a good way to look at that, but if you think about it, there are other ways besides just looking at it and saying, oh, well, this minus charge looks like it could use a proton, so it's a base. Actually, it's better to go ahead and use, let's see here, let me get my periodic table here. Crud. Go back to paint. Alright, so as you can see on the periodic table, the trends go from left to right and increasing acidity. So if we look here, oxygen is more acidic than nitrogen on the periodic table. If we draw from left to right on the periodic table, that's increasing acidity, and if we go from top to bottom, that's increasing acidity, and that can deal a lot with electronegativity and atomic radii, and we'll get to that in the future. But as for now, this is just the part of the lesson where all we need to know is that going left to right is more acidic. So okay, oxygen is more acidic. It'll release its proton much better than NH2 will. Okay, so it wants us to draw the products now. So when we draw the product, we already know that the acid is going to donate an electron, and the base will accept one. So when we draw it, we can just draw it like this. OH2. Never forget your positives on there. And whoops, don't listen to me there, sorry. Never forget your signs. And then NH2 will receive it, so NH2 then becomes NH3. Okay, and now when you draw these out, they want you to label the conjugate acid and the conjugate base. So when you look at this, you can just kind of tell, and really what happens is that it flip-flops. So on top of this looking like it could receive a proton now, it also will just flip-flop from acid to conjugate base. Conjugate base. And now this one appears that out of these two, it would be more likely to release a proton. So this now becomes a conjugate acid. Okay, likewise on this example, the conjugate acid, or the starting acid is going to be the one that can release a proton. Well, we have oxygen in both of these, so we already know those are going to be acidic. But which one is going to release a proton? Well, this oxygen doesn't even have a proton. So we know that this is going to be the acid, and then this one will be the base. And then when we run the reaction, we get now this becomes the conjugate acid, and this one becomes the conjugate base. Whoa. Okay, and I'm going to continue on. Since this chapter has a lot to do with acids and bases, I'm going to do a little bit more work on that so that you guys get a better grasp of what's going on with the acids and bases in organic chemistry. Thanks. Bye.